Hello and welcome to Science Video Courses. In today's lesson we're looking at electromagnets and their uses. So what we're trying to fulfill from the specification is describe applications of the magnetic effects of current, including action of a relay. New words there to check out. So first of all, electromagnets. Now very simply, this is what they consist of. We've got a switch, got a battery, so we've got a current flowing through a coil and a soft iron core, and that is essentially all you need to have to create or to make an electromagnet. Now unlike bar magnets, which are permanent magnets, the magnetism of electromagnets very usefully can be turned on and off simply by closing and opening the switch. So when a current flows through the coil, it produces a magnetic field. This field is temporary and is lost when the current is switched off. And we can increase the strength of our electromagnet by increasing the current flowing through the wire or increasing number of turns on the coil. Now the coil is usually, or the core is usually made of a soft metal such as iron or an alloy like mu metal. So how can we use electromagnets? Many ways, quite surprising. Electromagnets are used in relays. Now relay is a device which uses a low current circuit to switch a high current circuit on or off. And a really good example of this is in a car. For example, a very big relay is used in cars for switching the starter motor. That starts the engine turning because it draws a very big current. A lot of energy is required to actually start the motor, to start turning it. So we need a big current, but in order to turn this big current on, we use a small current in a low current circuit. So here's the circuit. We've got here a low current circuit. Here's our coil. Here's an armature. And this is the switch contact that will kick into place the high current circuit. Let's see what happens. So first of all, number one, when the switch is in the low current circuit is closed, that's here, when this circuit is closed, it turns on this electromagnet. Electromagnet then attracts this armature. This armature pivots around this point here. The armature pivots and closes the switch contacts here in the high current circuit. And when the low current switch is opened, i.e. turned off, the electromagnet stops working and the high current circuit is broken. So as long as you are turning the key, you are turning on the low current circuit, attracting the armature and opening the high current circuit. But the moment you stop turning the key, the circuit is broken and the switch contacts separate again. Electromagnets are also used in what we call circuit breakers. Now when I was young, we used to always have fuses in our house controlling the electrical safety. These days fuses are not used so widely, and instead we use what are called circuit breakers. Now a circuit breaker does the same job as a fuse, but it works in a different way. Now circuit breakers are automatic switches that trip or turn off when the current rises above a specific value. For some reason, a fault in your electrical circuit, you get a current surge and that trips the circuit breaker. And nicely, the circuit breaker can be reset by pressing a button, no need to replace. I can remember my dad many years ago having to sort of go in the dark under the stairs to try and replace a fuse. No more. These days we simply press a button on the circuit breaker and the whole thing is reset. Much easier. And here's an example here of a circuit breaker. Essentially you've got electromagnet here and you've got a spring-loaded soft iron bolt here. Now at the moment there's no attraction between these two, so this bolt stays in place, stopping this from moving. So a spring-loaded push switch is held in closed position by a spring-loaded soft iron bolt. Now the electromagnet is arranged so it can pull the bolt away from the switch. If the current increases beyond a set limit, then the electromagnet pulls bolt towards itself. So if there's a surge, if it's a current surge, this electromagnet here, gets turned on. That attracts this bolt, which then releases this switch, which breaks the circuit. So the current increases beyond a set limit, then the electromagnet pulls bolt towards itself, releasing the push switch, breaking the circuit. Now electromagnets are also used in magnetic storage. So pictures and sound can be recorded onto magnetic tape. So not so long ago we'd have cassette tapes, we would have videotapes, and they consist of long thin plastic strip coated with a layer of iron oxide that can be magnetized. And here's the sort of setup it used to be. So first one, number one, a microphone picks up sound waves and converts it into small changing voltage. Now number two, the amplifier amplifies this voltage. And 3, output from amplifier fed to recording head, which is here, where changing magnetic field is produced, and that has an impact on the particles of iron oxide on the tape. So the changing magnetic field arranges iron oxide grains onto a pattern that mirrors the changing sound input. So these iron oxide particles here get orientated according to the movements of the microphone, amplifier and magnetic tape. These all contribute to moving the iron oxide grains into a pattern. Now at the simplest level, a computer hard drive is not so different from magnetic cassette tape. Both hard disks and cassette tapes use the same magnetic recording techniques previously described. And it is our hard drive. So the recording head, which is this little point here, contains a tiny, really tiny electromagnet which is used to create tracks of varying magnetism on the spinning disc, which goes round like this. Okay? Hard disks and cassette tapes also share the major benefits that the magnetic medium can be easily erased, you can wipe it clean and rewritten and remembered for many, many years. I've still got cassette tapes I made 30 years ago. So that's the end of this topic, electromagnets and their uses. Hope you enjoyed it, and I'll be back with another lesson very, very soon. So bye bye for now.